Okay, good morning. Welcome to
Family Math number 150.
Family Math number 150. So yesterday we talked about some fun relationships between Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6. Oops. 1, 4, 6, 4, 1. And counting blocks, polynomials, and binary. Remember the binary relationship? Yeah. We said if we wanted to pick from our sets of 4 blocks here,
We wanted to pick,
each combination either had 0 or 1.
and that would relate to binary.
And that related to binary, and that helped us understand why the rows summed up to be powers of 2.
Yeah.
So I just read some, 2 actually really interesting books. One is called Love and Math by a guy named Ed Frankel. And do you love math?
Yeah.
Yeah. How come I only got one answer there? Do you love math? Unclear yet, okay. And another one by a guy named Jordan Ellenberg called How Not to Be Wrong. And both of them talk about a lot about these relationships between seemingly very different ideas.
Yeah.
This is just a triangle of numbers. These are counting blocks. These are polynomials. That's binary. What does this have to do with each other?
Wow.
Doesn't seem like anything, right?
No. Yeah.
It turns out they're all related in a really cool way.
Whoa.
And we're going to use these relationships to today to help us solve a slightly more difficult problem. But just for one quick reminder, in the 4th row here, 1, 4, 6, 4, 1, this tells us how we can select 0 blocks, the number of ways.
Yeah.
This is 4 is the number of ways to select 1 block. 6 is the number of ways to select 2 blocks. And I've shown this here on the side. I have this group of purple, green, yellow, and blue. And here are the 6 different ways you can pick 2 blocks from it. So you see that?
Yeah.
Okay, so today we're going to work on a little bit more challenging problem. And we're going to use these ideas of looking at it in a different base, looking at it as a polynomial, and looking at it as a triangle to try to help solve a block counting problem.
Cool.
And the block counting problem we're specifically going to look at today is this. Instead of having 1 block of each color, I'm going to have 2 blocks of each color. Okay? And the reason this is a little bit more complicated is, first of all, you just get more blocks.
Yeah.
So I only have 2. The first interesting one is going to be 2 blocks, and 4 blocks, and 6 blocks, and 8 blocks. So the numbers get bigger a little bit faster. But also, one other thing that makes this problem a little bit more complicated is when I select, say, this group of 2, say I'm trying to pick 2, it's the same as this group of 2, right? And it's also the same as that group of 2.
Half of them aren't going to count.
Well, I don't know. Look how many different ways I can make these the same.
4 different ways.
Yeah, there's lots of different ways. So it's going to be a little harder to tell when 2 groups are the same and when they're different. A little harder, right? Like it's easy to tell that yellow and purple is different than green and purple, right?
Yeah.
So, but we're going to use these ideas that are really important ideas in math, of all these different relationships, and we're going to be able to write down a triangle, just like Pascal's triangle, and we're going to be able to write down a polynomial that counts all these combinations just like we did last time.
Cool.
You ready to do it?
Yeah.
All right, here we go.